Welcome to today's webinar. My name is Tom Carpenter. I'm the CTO at CWNP, and we're excited to have the folks from Arista with us today. This is part of our Week of Webinar series, and Arista is one of the sponsors of Wi-Fi Trek this year. So they have the opportunity to speak to our audience through a webinar format like this. Now, this webinar is being recorded and will be archived at CWNP TV, the YouTube channel for CWNP. So if you haven't already, make sure you go to YouTube, search for CWNP TV, all one word, and subscribe to the channel so you can be notified whenever new videos are posted. Well, we're just around the corner now from Wi-Fi Trek. It's just a few weeks away. If you haven't already registered, make sure you either go to cwnp.com and click on the conference advertisement, or go directly to trek2019.com. That's TREK 2019.com, so that you can find out all about the conference and get registered there. We're excited to see you at the event this year. We have excellent keynote speakers and a lineup of great topics of presentation for the conference, and also our pre-conference training for CWNA, CWSP, CWAP, CWDP, CWS, and CWT, and even the new CWSA. So a very fun and busy time in Nashville, Tennessee this year coming up in just a few weeks. Well, with that said, I'd like to turn things over to the folks from Arista and let them talk to you about their technologies and how they solve some of the problems that you might be facing in your wireless networks.
Hello, everyone. My name is Brian White, Director of Wi-Fi Systems Engineering and PLM here at Arista Networks. And today we're going to talk about our cognitive Wi-Fi product. Over the years, Wi-Fi has evolved mainly from autonomous access points in the late 90s into controllers in the mid-2000s. Where controllers were used to aggregate many autonomous APs into one management plane. Typically, they would aggregate that into a single data plane to where the controller was the single point of egress from the entire wireless LAN. And with scale, it required multiple controllers. Then the controllers needed a management product. There's annual support costs. There's hardware involved in this. There's HVAC for those hardware. And over time, while controllers solved many of the problems that Wi-Fi was facing as it expanded in the mid-2000s and the proliferation of Wi-Fi connected devices, a few problems came about, mainly due to cost, mainly due to complexity, and that birthed the first generation cloud providers. These providers basically took what was a controller and virtualized that and put it in the cloud. That sometimes required control plane functions to also live in the cloud. So automatic channel and power, maybe some wireless intrusion protection policies, those processes ran in the cloud. And so therefore the access point needed, connectivity to the cloud at all times. There's additional licensing for security and analytics, multiple SKUs. So they basically took what the controller product was and took the controller hardware and put it in the cloud, but they didn't make any massive architectural changes. For Arista, our system, while also being cloud managed, is very architecturally different. There's no separate licensing for different parts of the product. It is API driven, and all of the access points are independent, and they collaborate together to provide roaming and control plane functionality and so on, which means that we can scale to massive amounts of APs without there being a single point of, I don't want to say single point of failure, but single point of control with a controller function, meaning managing the control plane. So this is the evolution of Wi-Fi over the past 20 years. So what are the four main points about Arista Wi-Fi that you should take from this? Number one is our cloud platform. We started to build this platform in the early 2010 timeframe. It was really about aggregating thousands of devices, multiple tens of thousands of devices under a single management plane. But we were able to scale to members mainly because of our architecture, which we'll get into in a little bit. The next thing on the list is what we term cognitive Wi-Fi. And if you think about a cloud platform, one of the biggest advantages of the cloud platform is really the concept of unlimited compute, unlimited storage. And we started to ask ourselves, with that power, what could we do for a network administrator? And if you think about wireless networks, they're extremely dynamic. Channel changes, client roaming, interference, adapting to the environment, and all of those create really artifacts within logs and things that you can go reference later. However, in the controller environment, they roll very fast because that's a finite amount of computing hardware in a controller, or you offload it to some third-party system that really has no context of what is going on in the wireless network. So we started to think, okay, well, why doesn't the network itself save all of that data, ingest it, apply analytics, and basically automate the troubleshooting process for those administrators? And this is what birthed the concept of cognitive Wi-Fi, which we'll get into later. Another unique thing is most of the Arista access points that are on the market contain a third full-time scanning radio. This is unique in the market in that it's a 2x2 radio. This comes from our WIPS background. We want to maintain visibility of the most common client connection capability there is on the market, which is, most clients are 2x2. So we want to increase the visibility to that. So that's fairly unique. But this radio scans 24/7 and is completely independent from the client radios, which gives you smarter radio resource management. It gives you more powerful wireless intrusion capabilities. And as well, we started to include client simulation within the product, which I'll get into in the later slide. And then everything we do is API driven. In fact, our entire UI is driven via the underlying API, which means customers have access to that as well. We have certain customers that never use our UI because they've written their own automation applications, and they've written interfaces into their CRM networks or customer loyalty networks, and it's all done via the API. There's many things that customers can take advantage of there. So everything that we do is available there. One of the unique things about the Arista Wi-Fi architecture is that the management plane being completely separate from the control plane that lives on the access points, and there is no dependency between them. The cloud is simply the management configuration, the reporting side of the product, whereas the control plane, automatic channel and power, wireless intrusion protection policy, roaming, all of the control plane functions of the access point are distributed out to the APs. The cloud is involved in none of those functions. So therefore, that gives a bit of independence, if you will. So if the access points lose connectivity to the cloud for whatever reason, they continue to authenticate clients. They continue to allow clients to roam. They still enforce wireless intrusion protection policy and continue to do channel and power changes if needed, because these are completely independent functions from the cloud. As well, we support a flexible data path that allows us to controllers, meaning that we can tunnel this traffic to certain endpoints. We support EOGRE. If you want to terminate this traffic on a router or a firewall, if those devices are capable of EOGRE. We also support VXLAN, which allows us to tunnel traffic to Arista switches. And if you have Arista switches in various places of your network, you can take advantage of this. As well, we have deployments where in the place of, say, another controller, we put an Arista switch and it terminates the SSID traffic there, tags it to a VLAN, and sends it upstream, which is exactly the data path of a controller. The goal with that is I have the flexibility to displace a controller architecture without you having to redesign your underlying network. Option for tunneling is actually on a per SSID basis. So whenever you're defining an SSID, you're basically saying this SSID is locally bridged, tagged with a VLAN and sent out the Ethernet port of the AP, or it's tunneled using EOGRE or VXLAN, and this is the tunnel endpoint. So very similar to a controller data path there, but you have the flexibility to send that traffic in different directions if you'd like, locally bridged if you'd like, and so on. One of the challenges with many cloud managed systems is the interface between that cloud management system and, say, existing NMS systems or SIMs that are locally placed on a customer network. They're located locally there. And we created this mode in an access point called a cloud integration point. And this allows a conduit, if you will, between the cloud and these local network systems. So again, I can displace a controller network without having to redesign, punch holes in the firewall, or abandon current network processes that I may have, such as interfaces to ServiceNow or Remedy, where there's an automatic ticket created based on an SNMP trap, or some security incident into ArcSite based on a certain syslog, and so on. So we also support that through what's called the cloud integration point. If I had to sum this up into 4 pieces, basically, about having the Arista Wi-Fi adapt into a large enterprise, I would basically say we've done a lot of work to fit like a glove in the underlying network design. What I mean by that is I can displace that controller, I can do the same tunneling, I can interface to the same network management systems and so on. That means that I really don't have to change my existing processes or network. It makes it easy for you to digest a cloud managed network system into your network very easily. Because there's no central controller, there is no single point of failure. And so therefore, redundancy and reliability is kind of inherent to the system. Even if you're tunneling to a specific endpoint for that SSID, we do have a primary and a secondary tunnel termination definition within the system. So you do have data path redundancy, but as well as control plane and management plane redundancy, everything is highly available by default. There's no special license. There's no other architecture that you need to do. We also took into consideration if an enterprise wanted to go to the cloud, what would be one of their concerns? We think security would be one of the concerns. So many cloud network providers advertise that they are they're housed in an SA16 data center, certified data center, and that governs access control, environmental security, that sort of thing. But we took it a step further, and actually we go through SOC 2 audits. And for SSA 16 SOC 2 compliance, which really is about how the cloud application is managed. So it's who has access, is it the auditing and governing background checks for support personnel. There's all kinds of things with regards to this SSA 16 SOC 2 that we're very unique in the cloud managed network vendors because we go through that. We also have FIPS 140-2. We do a lot of work with the government. Everything we do back and forth is AES encrypted, both at rest and in flight. And then again, everything we do is API driven. You can push config, you can create new folder structures. If you're running a managed service provider type setup, you can create new customer records. You can also pull data from the system. You can pull masses of guest access data, for example, or you want to do real estate utilization. You can pull API reports from the system and import that into your facilities software. So it's very extensible and flexible for that. So now we get into one of the main problems that Wi-Fi administrators get to is that Wi-Fi almost always gets blamed for poor user experience, even when it's not the direct cause. I'll use this example of I have a wireless client that's attempting to authenticate to a wireless network, but the radius server is not answering. The end result of that to the user is that the Wi-Fi is terrible. The Wi-Fi doesn't work. But let's say the radius server did answer and authenticated that client, and they got through that first little hurdle, but the DHCP server scope was full and it didn't hand out an IP address. What's the symptom to that end user? Well, the Wi-Fi sucks. It's terrible. It's not working. But let's say the DHCP server did respond with an IP address. So now the client is authenticated, the radius server answered, it's got an IP address because the DHCP server assigned one, and now DNS is not resolving the host. What's the end result to that user? Is that the Wi-Fi sucks. It's not working. And those three symptoms look exactly the same to the end user for the most part, but they're very different troubleshooting paths. Looking at a certificate authority or a radius server, looking at a DHCP server and its scopes, looking at a network path or a DNS server. Those three things are very different. The network should know the difference between those scenarios and automatically tell the network administrator what's going on. So we break that transaction down into certain sections between association, authentication, the network, and the application to really bring out to the surface what is going on with these issues. Within one click of a network administrator logging in the system, you see this across the screen. What we feel is that user experience is what matters most, whether that user has a good experience or a bad experience. And that's really the metric by which all Wi-Fi connections are at the end of the day judged by. And so what we've kind of birthed is this concept of cognitive Wi-Fi, where the system is always looking at these events and logs and collecting data from all of the dynamic transactions that are going along within the entire wireless network and bringing it up to the surface to really assist network administrators in getting their job done. It leads you to what matters most, really the things that are in red, and contains a complete analysis of the entire wireless experience. So this is what we call the client journey. And this is an example of there's 3,300 clients there. Looks like all of them passed association, but we had 18 that failed authentication. If you mouse over to the 18, you click on that, it'll give you a list of the entire 18, all of the clients that are having problems. That allows you to drill down into exactly what's there. And many times there's an automated packet capture there waiting for you to really get to the bottom of what's going on. And those can be saved for a while, because many Wi-Fi problems don't get reported in real time. Very rarely do you get Bob from finance calling you and saying, hey, I'm in this conference room right now, and I'm having this problem. Can you come help? Usually it's anecdotal, days or even weeks later. Oh, hey, I was over in this conference room 4 or 5 days ago, and we were having this problem, and I couldn't get on the Wi-Fi network. Well, if in a typical wireless architecture or system, that data is gone. I would have to be there real time. For us, you go back and look in the logs, you'll see exactly what's going on, and most likely there will be a packet capture there waiting. We also do a breakdown of distribution of problems across different protocols, different operating systems, and vendor types, really looking at are the majority of these problems really centered around certain types of devices? Are your iPads the problem child of your user population, or are these particular Windows notebooks that you just upgraded the driver, are they now having a lot of problems? And you can root cause that to the time that you guys upgraded the driver. So we do a distribution in a kind of a breakdown. So this is what we're looking at. We're really watching everything that's going on in the wireless network. From client connection training, which includes the DHCP latencies, DNS latencies, authentication, captive portal, roaming and steering, whether clients are sticky, whether they've roamed correctly, etc. Device fingerprinting, device type, OS type, application fingerprinting. We have an application awareness engine that runs in every AP, can track about 1,500 applications. So we actually show you which applications users are using. As well, we take that one step further with certain real-time applications in a performance dashboard, which we'll get into. Look at flows, look at RF monitoring, and all of that is real-time streaming to the Arista cloud, and for reporting within the cognitive Wi-Fi management screens. We also support OpenConfig, and this is fairly new. We've had a few customers go through the process of wanting to support kind of an open vendor management system, and that it requires doing the streaming telemetry and the configuration via OpenConfig. So I invite you to go out to GitHub and look at the OpenConfig repository, but we're now supporting that for operators who want to use multiple vendors with a single management API interface. We also do baselining. We kind of come to the conclusion that what's good for one location may be problematic for another location. If you think about it, I might have a small quiet office where 15% retry rate is completely normal. I might have another location where a small place where 15% is completely normal and 40% retry rate is a problem. I might have a large auditorium that's a large population of people where 40% retry rate during a certain event might be kind of normal, just based on the number of devices that are contending for that spectrum. So we baseline each location and we bring out the anomalies. And here's an example of this 15-minute period. The baseline of connection issues really was about 2%. For that 15-minute period, that baseline was 18%. And so we pop out the anomaly, and you can drill down and you can see exactly what was going on and what made that so different than the rest of the time that the baselining was collected. We also learn the application experience for various users. Here's an example of a poor user experience. Here's an example of a good experience. So what the access point is doing is it's taking 30-second detection chunks, and it's analyzing that, combining that with bit rate, packet rate, TCP, UDP statistics, and comparing that to a trained model that's in the cloud. So we've actually trained models of certain real-time applications, figuring out what is a good experience and what is a bad experience. And then we break that out into a UI that looks very similar to the client journey. This is what it looks like. Effectively, that GoToMeeting had 32 people using it, 12 people were having problems. Again, I can click on that 12, it'll give me the list of issues. possibly depending on what the issues are, there may be a packet capture waiting there for me, etc. So this has been very handy. We actually have quite a few users using this for their collaboration applications and doing pre-testing with them in before board meetings or before important functions within the organization. And here's the historical logs. For example, in this case, Skype, 21% of that time in that kind of was like 40-second period, 21% of that time the client experience was bad. We think the potential cause is wired. So how do we figure that out? We basically rule out anything wireless because we're looking at all the wireless stats, the retry rates, the noise floor, the data rates, and so on. And we basically say, hey, there's no issue here. We think the issue is wired. In the future, with Arista and the Cognitive Campus, we will also be looking at statistics from the wired switches. So Arista switches support an extreme amount of streaming telemetry, and we are working to incorporate those data points into the cognitive networking environment so that you can really drill down through your network up to a certain wired switch device or a certain port or path out of the network and so on. So that is the roadmap really for Cognitive Campus moving forward. We also do root cause analysis for this core user experience. So we can look at this and say, we think this is the problem, and you can click on the little blue light bulbs and it will actually give you a recommendation. Add more APs here, enable this function within the product, and so on. And again, we're offloading the troubleshooting and the work that a Wi-Fi administrator would normally have to do manually. We're trying to automate that process, make that network administrator's life easier. This is how it's happening, right? So if you had a device that had poor application experience, that might be due to high retry rate. A high retry rate in Wi-Fi is very common due to contention, due to number of devices there, people that are transferring heavy files and so on. So that sometimes that's transient, but if it's pretty constant, then that really results in the poor application performance. But high retry rate can be caused by many things. It can be caused by low SNR, for example. Low SNR then could be by I'm really far away from the AP, low RSSI, or it can be caused by high interference. High interference can be caused by Wi-Fi devices or non-Wi-Fi devices. RSSI is that because I don't have enough APs in that particular area? Do I have sticky clients where clients are holding on to APs for dear life where there's other AP candidates they could roam to? Or am I just sitting in the parking lot holding on to that Wi-Fi signal to send that last email at the end of the day, right? This is the domain knowledge that the system attempts to use to try to figure out, hey, this is what is causing the poor application experience. And again, the network devices know all of this stuff. It's really about how the system puts the pieces together to let you as the administrator know that this is occurring because of these reasons so that you don't have to go through the system and do that troubleshooting yourself. The system does it for you. That's what we term cognitive Wi-Fi. Most of our indoor access points feature a third radio, as I mentioned before. This third radio is multifunction, so it mostly does scanning for wireless intrusion protection events. It also does full-time scanning to do radio resource management. And because it's a dedicated scanning radio and it scans so fast and so frequently through all of the channels in the band, the data with which the access point has to choose power and channel or to react to wireless intrusion protection events is very up to date. There is no delay. And this is a primary example. The 5 gigahertz at 20 megahertz channels, there's 36 channels. And if I'm going off channel to scan every 10 seconds, because I'm using my client radio to do so, I can't do full-time scanning with that client radio because I have to serve clients. It's going to take me over 6 minutes to get through all of those 36 channels. Whereas with a dedicated radio, it's taking just above 3 seconds to do so. That gives me the capability to detect rogue access points much faster. Because I'm hitting every channel in a faster cadence, I might find that rogue access point in under 5 seconds. And an AP that's using its client radio in background scanning mode, sometimes that can take up to 5 minutes. Think about every 10 seconds, and I have to go through 36 channels, how long that takes. But while APs are relatively easy to find because they're always beaconing at the beacon interval, which is typically 100 milliseconds, clients don't always transmit. So if you go to a certain channel and sit there for 100 milliseconds or 500 milliseconds and listen, you may not hear that client transmit in that time frame. You might take you 2 or 3 or 4 scan cycles to get to that specific channel at the same time that that client is transmitting. For us with the third radio, that generally takes 10 or 15 seconds because we usually detect it in 3 or 4 scan cycles. This also means that over-the-air blocking and containment is completely unaffected. I can go to channel 9 and mitigate that rogue, or I can go to channel 44 and you can correct that unauthorized client connection. We also support within our wireless intrusion protection system the concept of marker packets. This is how we detect rogue access points. This is very unique to us. It's patented. The access points attempt to send frames on the wire and look at them coming out of the radio of the rogue AP, the possible rogue AP. We also try to send packets through the wireless side and see if they come out on the wired side. So we're attempting to complete the loop where there is a near 100% reliability rate on detecting rogue APs and making sure that they're rogues, which allows you to do containment with great confidence. There's very little room for false positives. I mean, if the system says it's a rogue, it is absolutely rogue. I hesitate to use 100% in the security world, but we are near 100%. The other thing we started to think about is what else can we do with this third radio? It's a free radio sitting in the AP. Why can't we turn it into a client, have it associate and authenticate to neighboring access points, and run a series of tests? And that's exactly what we've done. So you can go through and define a test profile, and you can say it's going to associate, authenticate, get an IP address, do a DNS test, test the gateway connectivity, look at WAN latency. There's built-in speed tests. I can do voice call simulations where you can say, I want to do a voice call for 5 minutes or 10 minutes, and at the end of that, it will calculate the MOS score. We can do application tests, which is looking at IP reachability and HTTP GET performance. You can select here at productivity, social communication. There's a bunch of applications that are built in. You can also create custom applications or insert custom applications. Say if you had a credit card processing machine, you needed to test your IP connectivity, or you had a special website or internal intranet site that your users use, you can put that in there as well. So this is very powerful. And at the end of this, you get a result of the test. Latency, for example, but you can also kind of calculate issues on your WAN. If the WAN link is slow in the speed test, but the communication between the wireless client and the access point is fine, I can drill that down and say, oh, now there's a problem on the WAN that I need to go take a look at. This stuff can be automated. In fact, we have many clients that schedule this in the morning before the business opens. Imagine having a large retail network, and 2 or 3 hours before the retail store opens, I already have done a network readiness test for that location and maybe found out in 3 or 4 of my locations I can't access the credit card processing server. That's a very important business function that can be problematic if it fails. I now have a 2 or 3 hour head start before the business opens. The flip side of that is I can run this test at the height of the business day. So tell me the worst case scenario. What's the performance of my end users at the height of the business day? I can have that test run. And so anyway, these can be scheduled, these can be automated, and they will just inform you when issues arise. Again, taking that what a Wi-Fi administrator may do manually and automating that process. As well, I mentioned earlier the automated packet captures. If I'm looking at a problem in the logs, as you can see on the left, there's radius authentication failures. There's a little button underneath that says view packet trace. If there's a whole series of conditions that can occur that can kick the system off into doing a packet trace. And you can go reference this later. You can save it for up to 30 days, and I think in some cases maybe longer. When you click on this view packet trace, it opens up a graphical tool so that you can do collaborative troubleshooting and look at the packet capture much more effectively than you would, say, looking at plain Wireshark. And if you know about Wireshark, which is a great tool, but it is basically just giving you the packets and saying, here, you place the context. If you need to filter on certain clients, you have to write a kind of a filter rule on the top. For this, I just click on the MAC address. And here's an example. There's expert analysis of this packet capture. In this particular capture, there's 5 clients. 2 of them were having issues, as you can see by the red. And in fact, the issues that they encountered were EAT failure issues. If I wanted to go, kind of drill down on all the packet capture data client, I would just click on its MAC address, and then it would change this display to only be relative to that particular client. There are performance views, connectivity views, client and access point views, and then the raw frames themselves. If you look at the frames, it looks very similar to the just wire, like a Wireshark type display where I'm manually going through these. But this is all built into the system. I can also upload my own PCAPs here. If I've taken the caps to another device, and it will also do this expert analysis. So it doesn't have to be a PCAP that was created by a dynamic packet capture scenario. It can be a PCAP that I have myself and upload to this tool. And this is included in the system. And again, I talk about everything being an open API. Again, some customers are interfacing with their loyalty systems or their CRM systems. We have service providers that are using a field provisioning application. Let's say there's access points on a van. They don't know which customer or which folder they're applying to. They have an application on their mobile device that scans the serial number and places it, creates a customer record and places that device in that folder, provisions it. This is very, very powerful, and you can interface with a lot of your internal systems if needed. We also include a very full-featured guest management platform. It's cloud-based, it's built into the system, it's not separately licensed, and it supports most of the common guest onboarding options. Social Wi-Fi logins, username and password, you can create that with self-registration, pre-registration, host approval. We do SMS integration with many of the main players, and for hospitality, we support payment gateway functionality. And we also have a customizable web form if you would like to create custom fields for archival later. We also support a web-based captive portal design tool called Canvas, and this is a way for you to create very beautiful, dynamic captive portal pages with very little technical knowledge. For example, this is just done via the UI. I can upload graphics, I can move things around, I can change text, I can enable certain login types and disable certain login types, create videos on demand if I want my visitors to watch a video before they can log in, etc. The good thing as well is I can give access to this design tool just to the marketing team without giving them access to the rest of the Wi-Fi system. So that is very common, where the marketing team can go off on their own and create advertising. They can do certain campaigns. If you turn it over to kind of your global administrators, they can create localized captive portals for certain places around the world, or maybe there's a special event that they would like to change the graphics for that week. This is all possible with our web-based captive portal design tool. As well, you can get a lot of analytics from this guest system: presence, footfall, dwell time, user analytics about who's logged in, when they've come into the system, and so on. Here's an example of presence analytics. It does the breakdown of when visitors actually come to your location. Now, this is presence, so these people haven't logged into the Wi-Fi or anything. These are just people that are within RF range of your wireless network. There's also dwell time, how long they've stayed. We also support zone analytics. For example, this is a display of, in the past 7 days, 612 people have walked into the range of the green circle, the green access point, but 72 have walked into the blue. And this is useful for the retail sector, of course, but some of our enterprise customers also use this to get a feel for real estate utilization. And as well, conversion analytics. You can see how many people came into your location and then how many of those people actually used the Wi-Fi, the guest Wi-Fi, for example. So these are just some example analytics screens that are included within the guest management system of the product. So here are our access point portfolio. This is our family of 802.11ac Wave 2 access points. We support both 2 radio and 3 radio 2x2 products, as well as 2 radio, 3 radio 4x4 products. We have a 3 radio wall plate. That's the W118 to the right. It supports PoE output and has 3 gigabit Ethernet ports, and as well as 1 pass-through port. And then we have a family of outdoor products, the O105 and the O105E, which is for external antennas. That's the AP to the left, and that's a 2x2 2 radio outdoor product. We also support a C130E, which is an external antenna version of the C130 that you see there. And just released for shipping our Wi-Fi 6 access point called the C250. We purposely waited a little bit for entry into the 802.11ax marketplace because we wanted to support a full functionality 802.11ax platform. This access point runs the Qualcomm Hawkeye 2.0 chipset and supports everything in the 802.11ax standard, including OFDNA and all of the multi-user MIMO feature set. It's an 8x8 access point. It has a 2x2 third radio in it for scanning and client simulation testing, as we mentioned before, as well as supports BLE. And that's about it. Thank you very much for your time.
And thank you very much, Brian, for that presentation. Once again, there's no question and answer period for this webinar as it was pre-recorded, but I would like to thank everyone for attending, and remember, the webinar and its full content will be archived at CWNP TV on YouTube. I look forward to seeing you at the conference. Check out trek2019.com to learn more, TREK2019.com. Thanks, everyone. Have a great weekend.